In our last lesson, we talked about pattern recognition and inductive reasoning, and we used those two items to create conjectures and to find counterexamples to disprove conjectures. Our objective for this lesson is to recognize and also to create conditional statements and their component parts, and we're going to use that to establish a foundation for developing our reasoning skills. We will be analyzing if-then statements as they apply to mathematical relationships. So, a key concept includes conditional statements. Conditional statements are if-then statements, and there are three ways that we can represent our conditional statements. The first is in words. We're just going to write a conditional statement. If this is true, then this is also true. We can also represent our conditional statements symbolically, and in the red and blue with the arrow, this is read symbolically. If P, then Q. That arrow means the word then, and P is going to be our hypothesis. Q is actually called the conclusion. Okay, so the hypothesis is the part that follows the word if in our statement, and the conclusion follows the word then. In graphic representation, we can use a Venn diagram where Q, the conclusion, is the set of all things, and P is going to be a subset of that set then. So let's go ahead and get started with some examples. This one says, what are the hypothesis and the conclusion of the conditional of this statement? If an animal is a robin, then the animal is a bird. Excuse me. Our hypothesis here, remember that follows the word if, so the hypothesis will be an animal is a robin. The conclusion follows the word then, the animal is a bird. What would that look like as a Venn diagram? Well, the Venn diagram would include all of the birds in the general set, and a subset of that would be the robins. So here's one for you to try. What are the hypothesis and the conclusion of this statement? If an angle measures 130 degrees, then the angle is obtuse. Go ahead and pause the video and see if you can come up with that on your own. All right, I hope you had a chance to try that on your own. Let's see if you did this correctly. The hypothesis, remember, follows the word if. So what comes after the word if is the angle measures 130 degrees. The conclusion, then, we should have the angle is obtuse. Pretty straightforward. I don't think you'll have any trouble with those. Here's another example where we actually are going to write our own conditional statement. And the statement they've given us is that vertical angles share a vertex. So we need to identify the hypothesis. In this case, it's vertical angles, and then the conclusion, share a vertex. Okay? So to write the conditional, we need to add the words if and then. So if two angles are vertical, then they share a vertex. Okay, so you're just adding the words if and then and putting the stuff in between that you've already identified in step one. Here's another example for you to try. I think it's a good idea for you to pause the video and try it on your own, and when you come back, I'll give you the answers. All right, I hope you had a chance to go ahead and try that. Step one, remember, we're going to identify the hypothesis and the conclusion. In this example, our hypothesis is dolphins. Our conclusion is mammals. So our conditional should be if it is a dolphin, then it is a mammal. Pretty straightforward, right? When we're dealing with truth values, there are only two options. It's either true or false. And remember from our last lesson, we only need to come up with one counterexample to prove that a statement is false. So let's go ahead and jump into problem number 3, finding the truth value of a conditional. Is this a true or a false statement? If it's false, we need a counterexample. If it's true, we can just say that it's true. If a woman lives in France, then she lives in Europe. Well, what do you think? What's the relationship between France and Europe? Well, we know France is a country in Europe, so anyone who lives in France also lives in Europe, so that is true. How about example B? If a number is divisible by 3, then it is odd. Well, let's see. Let's try some multiples of 3. Or not, if we look at multiples of 3, 9 is divisible by 3, but that's odd. Let's try the next one. How about 12? 12 is divisible by 3, but that's not odd. So that would be a counterexample. 12 is divisible by 3, but is not odd, so that proves that it's false. Here are 2 for you to try. Go ahead and pause the video, and we'll see how you do. All right, I hope you had a chance to try those. Letter A says, if a month has 28 days, then it is February. Can you think of a counterexample, or is that always true? Well, obviously it's not always true because all of the months have 28 days, so any month other than February would provide a counterexample. So you could put any month in here you want. You could try January, you could try March. I'll put January in here. You could pick any month you want. Part B says, if 2 angles form a linear pair, then they are supplementary. Well, remember, a linear pair, they share one side, but they don't share any points inside the interior of their angles, and they always form a straight line, and a straight line is 180 degrees. Well, that's part of being supplementary. So actually, all linear pairs are supplementary, so that is a true statement. Here's your lesson check. Go ahead and try these and bring your answers to class, and we will discuss those when you get to class, and we will see you then.